Good morning or good afternoon, Tigers. Today we'll be watching a video on Math Notes page 7. So this is a little different than the videos that you guys are used to watching. You might have to pause this video at some points, play it, and then pause it so you have time to copy everything down. If I actually sat here and did the Math Notes the way that I do them live, it would actually take like 25-30 minutes, and you guys know YouTube has these laws where it has to be a video within like 13 or 14 minutes or something like that. So anyways, this is a Math Notes page 7. If you have something on page 7, you can do it on page 8. It honestly doesn't matter what page you use, but if 7 is open, go ahead and use 7. So this should be your top corner that you have free on your Math Notes page. And then you have another, I think it's like a red line. And we usually draw a Cornell line. And this is the Cornell line right here. It's usually like the measure of half of your thumb. At the top, I want you to write fractions, review. And you guys probably didn't write it in your index, so you can go to your index quickly and write fractions review, but don't get behind. So we are going to review adding and subtracting fractions. So on the side, just write adding and subtracting fractions. When adding and subtracting fractions, you must have the same common denominator. The rules of integers still apply with fractions. So in other words, if you have subtraction with fractions, you have to change it to the addition of the opposite. So addition, I'll give you an example as to what that means later. So I'm going to go ahead and write this definition down and go ahead and pause it so you guys have enough time to copy it. So go ahead and copy this down. When you add or subtract fractions, you must have the same common denominator. Note, the rules of integers still apply with fractions. At this moment, go ahead and pause the video, write it down as quickly and as neatly as possible, and then I'm going to go through the example. So the example reads negative 2/3 minus 1/5. The note tells us that the rules of integers still apply. Now, you can no longer subtract in math. You have to change it into the addition of the opposite. So remember, negative 2/3 stays the same. You change the subtraction into addition, and then the opposite of positive 1/5 is negative 1/5. So now that's addition of the opposite. Okay, now 3 and 5 are not the same number, so I have to find the same common denominator. Now, a strategy I taught you guys also that I shared with you is that you can just multiply the first fraction by the numerator of the second fraction, and then multiply the second fraction by the numerator of the first fraction. So in other words, I would multiply negative 2/3 by 5/5, and I would multiply negative 1/5 by 3/3, because that's the numerator of the first fraction, and then in turn I would multiply this by 5/5, and that will guarantee that I get the same number on both of those fractions. So I'm just going to write it in kind of small. So I'm going to multiply this. I'm going to multiply this by 5/5. And then I'm going to multiply the second fraction by 3/3. So that way it'll get me the same common denominator, which in this case, the lowest common denominator happens to be 15. So 5 times negative 2 is negative 10. And then 5 times 3, which are the numerators, is 15. Plus negative 1 times 3 is negative 3. And then 5 times 3 is 15. Okay, now that they have the same common denominator, I can combine the top numbers. So now I'm just going to rewrite it over here. Negative 10 over 15 plus negative 3 over 15. And the numerator stays the same. And the denominators stay the same. And the numerators, negative 10 plus negative 3, those have the same sign. So you add them together and you keep their sign. So I have negative 13 over 15. That is my solution. Okay, now moving on to multiplying and dividing. When you multiply and divide fractions, you do not need to have the same common denominator. You just multiply straight across. Division of fractions is something else. So when we multiply fractions, we're going to go ahead and write that first. Draw a line underneath your example and write multiplying fractions. I'm going to pause the video so I can write it, and then once I write the statement, you'll pause the video, copy it down, and then get the example. when you multiply fractions, you must multiply the first numerator by the second numerator and the first denominator by the second denominator. In other words, you multiply straight across. The numerators, you multiply straight across, and the denominators, you multiply straight across. Go ahead and pause the video so you have time to copy this down, and then play the video so you can see the example. Okay, so we have negative 3/5 times negative 11/4. You multiply the numerator, the first numerator, by the second numerator. Negative 3 times negative 11 is positive 33. And 5 times 4 is 20. So you have positive 33 over 20. Now, if you want to get the mixed number, which I always recommend, you divide the numerator by the denominator. 20 goes into 33 evenly once. You have 13 left over. And since you have 13 left over, it's 13 20ths. But let's say I wanted to get the decimal. If I want to get the decimal, let me erase that. You erase it as well. You get 33 minus 20, which is 13. Put the decimal. Bring the 0 down. 20 goes into 136 times. 6 times 20 is 120. You have 10 left over. Bring down another 0. 20 goes into 100 5 times. So your answer is 1.65. These are all equivalent. So if you ran out of room on the first page, you can now continue on the back side of page 7. If you still have room on the first page, you can stay there. That's fine. But go ahead and draw your Cornell line. So again, your paper has like this natural red line. You're going to draw your Cornell line. And it has like another red line somewhere over here. Like kind of far. All right, so on the back, we're going to write dividing fractions. So most of you guys were here when I taught this last week, but if you weren't here, here it is on in the notes section. So when you divide fractions, I'm going to go ahead and write this, and then you guys can pause it after to catch up. So when you divide fractions, you must flip the second fraction and multiply. Now, this is essentially what you're doing. I'm going to try to answer the question as to why do we flip the second fraction and then change it to multiplication when they're asking you to divide the fractions. So I know I'm talking a lot, so go ahead and pause the video, copy this down, and then play it when you're ready to understand what I'm about to explain. Thank you. So we have 3/5 divided by 2/3. Now, if you were to rewrite this, you would have 3/5 divided by 2/3, right? So I already taught you the ear method, but let's pretend that you don't know the ear method. So if you were solving this as a fraction, just as it's written right there, you would want to multiply by the opposite. So you would want to multiply the numerator by the opposite of 2/3. The opposite of 2/3, or the reciprocal, would rather, that's the best word. The reciprocal would be 3/2. Do you see how I just flipped the 2 and the 3? Now, if I multiply that to the bottom, I have to multiply that to the top. So this is another version of 1. 3/2, if I multiply it to the bottom, I'm multiplying it to the top. It's keeping it proportional. That's like if I were to multiply both of them by like 5 and 5. I can do that. I can maximize it by 5. But in this case, I'm maximizing it by 3/2. So if I do that, 3 times 3 is 9. 5 times 2 is 10. Now keep the fraction. 2 times 3 is 6. And 3 times 2 is 6. Hey, 6/6 on the bottom, on the numerator, isn't that just 1? Because 6 goes into 6 one time? Yes, it is. So now this is 9/10. And then the bottom, the denominator is 1. Hey, 1 goes into 9/10, 9/10 times. So that's equal to 9/10. So you don't realize that you're doing this math when you flip the second fraction and you change it to multiplication. But that's essentially what is going on. So you get 9/10. So let's do this the way you were taught. So you have 3/5 divided by 2/3. Then you keep 3/5. You change the division to multiplication. You flip the 3 halves. And then look, 3 times 3 is 9. 5 times 2 is 10. So this is still the same answer. Now, I'm going to formally teach you the ear method. And it's crazy that this actually works. So again, I'm going to write down the definition. You're going to pause it, write it down, and then listen to the example. Okay, so there's a lot to write here. Take it one sentence at a time. The black writing says, when two fractions are being divided, such as A over B divided by C over D, those letters just represent numbers. So pretend A is 1, B is 2, C is 3, D is 4. So let's say it has like 1/2 divided by 3/4. Rewrite them as a bigger fraction, so the other black writing. Go ahead and pause the video, only write the black writing, and then go ahead and unpause the video, and then you can write the blue and the red together. Okay, now we're going to write the blue and the red, but first listen to me explain it. Then you can write it when you guys pause it. So it says, connect the outside numbers and multiply them to get the numerator of your answer. It should say of your answer. So let me write that one more time. Of your answer. So let's point. So it says connect the outside numbers. So I connected A and D. So in this case, it would be 1 times 4. Because remember I told you it's like writing, here, let me write the numbers. So let's pretend this is like 1/2 and 3/4. So you multiply A times D, and that's 1 times 4, which would be 4. And then the red writing says, then connect the inside numbers and multiply them to get the denominator of your answer. So in this case, I would multiply 2 times 3. And 2 times 3, because those are my inside numbers, that gives me my denominator. 2 times 3 is 6 in this case. So I could write 6. So this answer would be 4/6, okay? Go ahead and pause the video, write the blue, write the red. Make sure that you connect them and actually create this ear looking thing. This is why it's called the ear method. After you guys pause it, I'm going to give you one more example, and it'll be the end of Math Notes, page 7. All right, so example 4 has a mixed fraction divided by a negative improper fraction. So I have 1/5 divided by -3/2. So the first step is to turn this mixed number into an improper fraction. So 1 times 3 is 3. 3 plus 5 is 8. So this is 8/3 divided by -3/2. Now, according to the ear method, I have to connect my outside numbers and multiply them. And that's going to be my numerator. 8 times 2 is 16. And my inside numbers are my denominator. 3 times -3 is -9. This is my improper fraction. Now, if I want the mixed fraction, -9 goes into 16 -1 time, and then there's 7 left over out of 9. Now, if I want the decimal, I'm going to divide 9 into 16. And remember, it's going to be negative, so my decimal is going to be negative. 9 goes into 16 one time. Put the decimal. 16 minus 9 is 7. Bring down the 0. 9 goes into 70 7 times, and that is 63. And if you notice, it's going to be a repeating decimal. You're always going to get 7, so I can just put a repeating decimal. So the equivalent decimal to this is -1.7, and I'm going to put that repeating little line on top. All right, guys, so when you're dividing a mixed number and an improper fraction, you always have to have them as an improper fraction. You can never have two mixed numbers and use the ear method. If you have any questions, go ahead and raise your hand, but please don't talk to your group. You guys need to remember your social skills and try your hardest to get an A+ with the sub, so that when I come in tomorrow, I'm very happy with your class and I reward you with an immense amount of marbles. Have a good day, guys.